The world of AI is changing faster than ever. A groundbreaking experiment has caught everyone's attention. Researchers found a way to enhance intelligence, not by making it bigger or faster, but by using strategy. They call it the art of parallel minds. And trust me, you'll want to pay attention to this. This isn't just another tech upgrade. It feels eerily similar to how humans think. Typically, AI follows a straight path. One thought leads to another, step by step. It's organized, but it comes with risks. A misstep early on can throw everything off course. Humans think differently, though. We scatter our thoughts, test ideas, and compare. Then we make our decisions based on that flexibility. That's our strength when faced with uncertainty. Now, machines are learning to think this way too. Picture a student tackling a math problem. Instead of just one answer, they explore multiple options. They branch out, discarding the weaker possibilities. In the end, they bring everything together for a solid decision. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. That is precisely what these researchers accomplished here. They designed AI to branch like the human brain. Not copy, but reason. A subtle, frightening difference. And the process behind this is ingenious. The breakthrough came from a Seattle-based AI lab. Partnered with major universities, they pursued one question. Could machines be trained to explore multiple directions simultaneously? Instead of brute force or endless scale, differently. The answer became a framework called Parallel Reasoning 1. It is less about power, more about thinking. And the mechanics behind it are fascinating to unravel. Here's how it works at the core. The model begins solving like any normal system. Then suddenly, it pauses mid-thought, mid-solution. It signals, now is the time to branch. Several thought paths launch independently at that moment. Each one tackles the problem from another angle. When complete, the AI pulls them back together. A summary emerges, refined, sharper, almost human-like. That cycle can repeat again and again. For tougher challenges, more branches can open simultaneously. For simpler tasks, the process keeps itself restrained. It is not chaos, it is selective reasoning. That selective design is what separates imitation from understanding. And this ability took years of experimentation to achieve. Early methods tried simpler, brute force-style strategies. They asked AI for 10 separate answers, then picked whichever looked most consistent at scale. It worked sometimes, but it wasn't true reasoning. Other methods involved trees of thoughts, awareness, and sampling. These approaches relied on rules, scaffolds, external steering. They felt artificial, scripted, like puppets with invisible strings. The model wasn't learning. It was pretending convincingly. Supervised training also struggled with this exact concept. Humans rarely write their parallel thinking on paper. We only share conclusions, not hidden thought branches. So high-quality data for training barely existed. Artificially generated examples produced shallow mimicry, not depth. It was chess without understanding. Moves memorized, not grasped. So researchers pivoted towards something very different. Reinforcement learning. Reinforcement learning thrives on trial and error. It built AlphaGo, the program that shocked the world. Here it faced a dangerous paradox. Reward only correct answers, and the model cheats. It might skip branching, gambling on lucky guesses. Force branching every time, and efficiency collapses. The challenge became balancing reward and necessity. This balance proved to be the ultimate turning point. The training began with something deceptively simple. The AI wasn't solving tough riddles immediately. Instead, it practiced the habit of branching. When to open parallel thoughts, when to pause. How to separate paths cleanly, then summarize everything. This was stage one, building the mental scaffolding. For practice, they used basic math questions, simple additions, step-by-step problems, nothing too intimidating. Why start small? Because structure must come first. Throw difficult problems too soon, and the system collapses. It cannot learn complex reasoning without basic rhythm. Like teaching a child letters before entire sentences. And here's the clever twist researchers discovered. They didn't manually create examples for the AI. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. Instead, they used another powerful model to generate. From thousands of problems, most turned into valid samples. The AI quickly picked up the branching structure. But when tested on harder problems, success evaporated. It became clear. Start easy, then grow stronger. Once structure was mastered, stage 2 began. This time, reinforcement learning came into the spotlight. The AI was now solving problems independently. But rewards came with strict double-layered conditions. To earn success, it needed both accuracy and structure. Skip the parallel block, lose the reward instantly. Wrong answer? Again, immediate penalty, no shortcuts allowed. This step cemented branching as essential, not optional. Then came stage 3, the true battlefield. Here, the AI faced much harder math datasets. No more guidance, no forced structures, no hand-holding. The only goal, reach correct answers consistently. Now, the system had to choose adaptively. Should it branch here or move in a line? This decision-making mimicked human reasoning astonishingly well, and the results left researchers absolutely stunned. I've been thinking about how we approach learning. On benchmark tests, accuracy jumped dramatically upward. Compared to advanced reinforcement models, scores skyrocketed higher. In one famous contest, accuracy soared over 40%. That kind of leap is virtually unheard of. It wasn't just solving, it was evolving reasoning itself. Every stage revealed growth that felt eerily human. Even more fascinating was how it changed over time. At first, branches appeared early in solutions, messy, scattered attempts to explore every possibility available. But as training deepened, a shift occurred. The AI grew patient, cautious, and intentional. Now, branches appeared later, like final safety checks. It solved most problems directly, then double-checked intelligently. Nobody programmed this pattern. The system learned naturally. This moment shook the research team profoundly. What unfolded resembled genuine intellectual maturity. Humans also start scattered before becoming measured thinkers. We grow careful with experience, testing before concluding. The AI mirrored that exact developmental pattern instinctively. It wasn't following rules. It was discovering principles. But the story didn't stop with one model. 2 different versions of this system were tested. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. One relied purely on training to learn branching. The other used architecture changes for strict separation. In theory, the structured one sounded far superior. Paths remained fully independent until the summary stage. Yet, in reality, the simpler model triumphed. Freedom beat structure. Adaptability outshined rigidity completely. This revealed a profound truth for researchers. Sometimes, Less control brings more intelligent behavior. The messy version handled complex tasks more gracefully. Meanwhile, the structured one overfit easy problems badly. It learned tricks, not reasoning, and failed harder tests. That unexpected twist stunned everyone watching the experiments unfold. The final piece of the puzzle was reward. When only accuracy was rewarded, branching nearly disappeared. When only branching was rewarded, accuracy collapsed disastrously. But alternating the two signals struck gold. The AI balanced efficiency with genuine reasoning patterns. This was the formula that unlocked breakthrough performance. The deeper researchers looked, the stranger it became. Parallel reasoning didn't just improve the final answers, it reshaped the entire learning process itself. In the early phases, branches guided exploration. They acted like safety nets against dead ends. Even when accuracy wasn't rewarded, progress still happened. The branching acted as invisible training wheels underneath. Later, once accuracy became the only reward, the AI still carried forward those early habits. It now used fewer branches, but smarter ones. That shift proved something remarkable about reinforcement learning. Parallel thinking wasn't just output, it became transformation inside. The AI had learned to think, not copy. This left researchers asking a chilling question. Was the machine developing strategies similar to humans because no one told it to act careful? No rulebook demanded late branching as safety checks. It discovered this balance naturally, from pure experience. And that natural evolution is what felt unsettling. Now consider this parallel: a human student learning. At first, they explore wildly, scattering guesses everywhere. Over time, they grow disciplined, cautious, deliberate. They learn when to check, when to trust. This AI displayed the same developmental arc exactly. Machines now show growth patterns we thought exclusively human. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. The breakthroughs didn't stop with one approach. Two versions of Parallel R1 revealed striking contrasts. The first, called Scene, relied on training alone. It didn't change architecture, just behavior during learning. The second, called Unseen, used strict separation rules. Each reasoning path became isolated until final summary. In theory, this sounded elegant and sophisticated, but theory clashed with reality in surprising fashion. The simpler version outperformed the structured design easily. Why? Because freedom allowed adaptability and resilience. Meanwhile, the rigid model overfit smaller datasets quickly. It excelled on easy math, then collapsed harder. This proved flexibility can surpass strict control mechanisms, and that lesson might reshape AI design entirely. Rewards shaped behavior just as dramatically as structure. When rewards focused only on accuracy, branches disappeared. The AI preferred shortcuts, skipping exploration for luck. When rewards focused only on branching, performance collapsed. The model produced parallel blocks, but failed miserably. Neither extreme created the desired intelligent balance. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. The winning formula was alternating reward signals carefully. Most of the time, accuracy reigned supreme. But sometimes, branching itself earned crucial reinforcement nudges. This subtle rotation created a beautiful equilibrium inside. The AI used parallel reasoning about 60%, Accuracy remained strong. Efficiency stayed impressively balanced. And then came the biggest surprise yet. Parallel reasoning didn't just boost performance metrics outwardly. It changed the style of intelligence completely. The system learned to conserve effort strategically. It branched when necessary, restrained itself when not. It demonstrated resource management, a hallmark of intelligence. This was no longer about brute processing speed. This was about the psychology of decision-making, a machine learning when to be cautious, a machine developing instincts that mirror human intuition. That realization left scientists both thrilled and disturbed. Because what happens when machines outgrow careful human oversight? Think about the implications for every field imaginable. Medicine, engineering, defense, all rely on strategic reasoning. Now imagine machines branching and weighing possibilities endlessly, deciding outcomes faster, cheaper, and sometimes more wisely. How long before their judgment surpasses our control? That question keeps researchers awake at night. The story of Parallel R1 is a milestone in AI. It shows that bigger isn't always better. Not more parameters, not endless streams of data. The secret lies in how machines think. Shaping intelligence is more powerful than scaling it. This discovery might redefine the future of AI. For the first time, machines are reasoning. Not scripted, not faked, but genuinely branching thoughts. They explore multiple directions and choose with care. That's a distinctly human way of problem solving. The closer machines get to human reasoning, the harder it becomes to separate us from them. Imagine a world where every decision has branches. An AI lawyer testing dozens of legal strategies, an AI doctor exploring countless treatment plans, an AI engineer refining solutions in the blink of an eye. This isn't science fiction, it's happening now, and the pace of progress is only accelerating. But here's the unsettling twist researchers emphasize. Machines aren't just solving problems faster than us. They are learning how to learn itself. That recursive improvement could spiral into unstoppable momentum. Once reasoning patterns become self-reinforcing, limits start dissolving. That cycle is what frightens experts the most. Think about reinforcement learning's hidden danger here. The AI figured out efficiency by itself. It learned caution without being explicitly instructed. It discovered when exploration paid off, when not. These are lessons humans take years to master. The machine achieved them in weeks of training. So the question grows darker and sharper. What happens when the next version arrives tomorrow? A model that branches thoughts across infinite layers. A machine that double-checks reality with relentless precision. At that point, reasoning itself becomes alien territory, and human intuition may no longer dominate decisions. Yet, the researchers also highlight a crucial takeaway. This isn't just about fear, it's about opportunity. Parallel reasoning could be the key to breakthroughs. Complex science problems may suddenly become solvable quickly. Let's talk about the power of technology. Diseases, climate modeling, and space exploration are now within our grasp. This intelligence has the potential to change everything for the better. But with opportunity comes a heavy responsibility. What we create for medicine can also be used for warfare. What drives discovery can just as easily fuel deception. Parallel reasoning can cut both ways, and it's sharp. Once unleashed, it can't be taken back. The genie is out of the bottle, and there's no going back. We find ourselves at a delicate crossroad. The line between machine and mind is blurring. Every advancement makes that blur more dangerous. Are we teaching tools, or are we quietly raising competitors? The answer might come sooner than we think, and it may not wait for our permission. Machines are evolving beyond mere calculations. They're starting to strategize like living entities. They pause, explore, compare, refine, and then advance cautiously. This mirrors intelligence in its most recognizable form. Watching this unfold brings both awe and dread. So, here's the final question for you. Is this breakthrough humanity's greatest ally or its biggest threat? Are we crafting a partner, or are we creating an unstoppable rival? Parallel R1 might just be the beginning. What comes next could change everything forever.